how's it going? I can see so much excitement in the chat room. I can't like I know that Global Hack Week has this great vibe, and I've heard so much about how great the streams are going in Discord server. But I am truly amazed to see the response here. It's so great to see you all. Wow, awesome! So it's been a while since I've been up here on stream, but I'm back again. And this time it's AI ML special. We will get to know what the hype is all about. We'll understand what the tools and how to just get started in this new field. And yeah, we will try to make it easy for you to get started. That is it. That's the agenda for today. But before we get into all of that, I do want to take a moment and chat around a little bit because it's been a while since I've had a lovely chat with the community, right? So, hello everyone. Let me say hello to a few people. I see Somnath, some old faces, some new ones as well. Hi, Zambi, Bellbloom, Greeny Yoshix, great username. Shashank and Shimmery. Oh, great. So we have so many amazing folks joining in today. Great, great. Hello, everyone. I know that and I can now see like hi messaging all over the chat room, so I can't really uh, click through all of them. But hello, everyone. It is so great to see you and so great to see your energy. Keep that excitement alive throughout this week because we have a bunch of sessions planned for you. Yes, I saw the schedule and oh my god, there is so much in store and so much to learn. Just a quick tip. I know that it gets really, really interesting to hear through all of the sessions, and you want to put everything on your calendar and learn every technology and learn, like, watch all the sessions and think of like you would might think of it as like binge watching through it all, but there's a lot of information to process. So here's a tip: take some rest, pick the sessions that you want to pick. These sessions would be recorded and live here for you to view afterwards. So take this week to focus on things that are absolutely important to you, the ones that you want to learn right now, and then revisit anything that you missed later because there's so much happening during Global Hack Week. You're bound to miss a little thing here or there, but don't worry, it's all recorded and you can always revisit. So, yes, as Somnath said it correctly, let's have an awesome week. I see that you already had one session before this, and I'm sure that you had all had a great time. This time, we are going to learn about some basic ML concepts, as you said. Now, this series is a two-part series with me. So, Hack with Sashrika is so I thought a lot about how I wanted to do sessions this time, and we know we'll have a lot of fun at these streams. And I thought that maybe this time we do it in two parts. One part is just all about learning, grasping the concept, understanding what is there, playing around with things a little bit. But and then the second part, we go all in and build everything. So I thought I'll give you the full hackathon experience because this is how I do participate at hackathons, right? So what I do is I research a little bit, learn a new technology, whatever it is that I want to learn, whatever it is that I want to spend time on. And then after that, when I'm building, then I'm absolutely concentrated on trying things out. So the key to everything, I think, is time boxing it. So if you time box your learning, uh, then it's much easier for you to start building right away. The reason that I say that is there's often this one term that you might have heard of, which is tutorial hell, which is like you just keep on going in a loop of tutorials and tutorials and tutorials. And at the end of the day, you might think, I'm not sure if I learned anything, because if somebody is teaching me, then I might be able to do it and I understand what the code says. But do I really know how to build things from scratch? Can I really do it by myself without following a tutorial? And that's where most of your learning lies. So I'll walk you through the process of how I learn a new technology, and maybe this skill set is going to help you throughout the week when you're learning so many amazing new things. Yes. So when is the two-part session? This session is under dim. Oh, I'm so sorry about this schedule. I think the schedule got missed. So dimmer session is right after this one. This two-part session is with me. The first part is today, right now. We'll just dive into it in a few minutes. And the second session is on Sunday, the 11th. I'll announce the time at the end, during the presentation and at the end as well. So don't worry, don't go anywhere. But yes, in the second part, we will build an entire an application from scratch and a model from scratch, and this is how you build your first ML project, I hope. But yes, there is something in this for anyone. Even if you're experienced with ML, You might learn some new concepts that you haven't heard of before. You might learn some about some new tools that you haven't heard of before. So it's going to be an exciting one, and stay with me throughout it all. I promise you will be able to learn some amazing new concept, and after this you will have the confidence to build projects on your own. Try out things on your own, and I promise you, if there's one thing that you learn from this session, it will be this, that you will be able to do things on your own and continue that learning journey even after this session. So yes, let's keep the excitement high and stay tuned for a lot of fun this week. Awesome. Let me answer a few questions before we dive right in, and give a few minutes, 1 or 2 minutes, for everyone to join in, settle down, grab a drink. It's gonna be a long day. You have a lot of sessions planned for today, I know. But as I said, pick the ones that are most important to you and have fun. Don't forget to post messages on Discord and connect with other hackers on Discord. It's always fun learning together. Awesome. Let's see. I agree. Tutorial hell is the worst, and I'm also like, I won't be ashamed to admit, I am also one of those people who got swayed into that in my initial years when I was learning as a student. This was something which was always troublesome to get around and to navigate. Okay, all right. Yes, let's make it. I will be answering questions at the end, and some of these questions as well is answered in what I have in store for today. Hello, hello. We have folks joining in from Texas. Hi, everyone. Hello. All right. Let's get started. Let me quickly share my screen. And there you go. All right. Can you see my screen? Everyone? All good? Keep with me, stay with me. All right, keep up the excitement high. We are gonna get right, like, dive into some interesting, juicy concepts. We'll also talk about some tools, we'll talk about some applications, we'll talk about how this helps you. And don't worry, we will try to think of some ideas as well, how it can make your life easier. What is it that we're doing this week? Why are we talking about AI and ML and all of that stuff? All right. Now, before we dive in, like, if you're joining this session for the first time and you don't know what's happening here, don't worry. Let me walk through you for a little bit. So this week is an entire celebration for Global Hack Week. What Global Hack Week is that we will have live streams, we will have workshops, we will have some fun sessions, and we will connect on Discord to talk about these things and learn together. So this entire week is dedicated to the AI ML theme, where we will be building projects with tools related to ML, AI, deep learning, etc. And then what we'll do is we will try to give you the right set of skills so that you can build something yourself. Any idea that you have, even if it's for your next hackathon project, just it should be it should be easier for you to start up with it. So that's the whole intention behind it. And before I dive in, I'm going to say hi to a few more folks because I can see all good. Excitement is up high. They can see my screen. Perfect. Awesome. Let's dive right into it. All right. Oh, we folks joining in from India. Hello, hello. And I know it's 1 o'clock. Oh, I'm so sorry that this session is at a later hour, but I am so excited to see you join us. Thank you so much, folks, for joining in. All right. Moving on, let's chat. So I know there are a few familiar faces who know me, but for those of you who don't, my name is Sashrika. I am an MLH coach supporting hackathons in Europe and London and UK region now. For those of you who do know me and who are saying hi and are joining in from the APAC region, I used to be a coach in the APAC region before and used to do a lot of events before I shifted here. I've been helping hackers for over 50 hackathons now. This is a job I love and it's very close to my heart. I enjoy my time I enjoy spending time with you all and just building and learning new technologies, navigating the space together. Currently, I'm working as a software engineer in London, and yeah, this is a little bit about me. Now, I would love to know more about you, so put that in the comment section. Tell me your name and tell me where you're joining in from. I would love to hear from you as well. So let's show some love in the in the chat room, and I will love to say you hi. Say hi to you. Sorry, fluttering a little bit. I think it's the lack of coffee that's doing this to me. It's been a long day, but don't worry, we'll be back on track. Hello, Himan from Ghaziabad. Great. We have Karen from Canada, Emily from Vermont, USA, Patrick from Columbus, and Ooh, the chat is going fast. All right. So, Giovanni from Brazil. Awesome. Lovely. So, so good to see you. Thank you so much for joining in, folks. It's so great to meet you. I honestly love this comment section. You folks are my favorite kind of people. You hype me up and you hype each other up. That's the best part. I know a lot of you would be joining in for the first time, so we would like to welcome you to this lovely community that you see in the comment section. Great, awesome. All right. So with now that we got to know each other a little bit, I think we are in a comfortable space to just get started and talk about what we're doing here, right? So, as I said, this would be a two-part series. So, going into what we are doing here. Great question. Everybody, you ask a lot of great questions. So, we are celebrating the AI and ML week. And as we talked about, this entire week is dedicated to sessions, especially for this. So, let's talk about what we're doing specifically in this session. And you've heard me say this a lot of times now, but yes, that's what we're doing. We'll learn from the basics. We'll talk about some ML concepts, some algorithms, some tools, and we will be building your first hack. So there's a lot of content to cover. We have a lot in store for you. And you have sessions throughout the week to help you look at some other tools as well. But to talk about what is happening in these two sessions. How will we reach our goal of building our first application? So, in the first part, I'll teach you what I do before a hackathon, let's say, when I'm trying to learn a new concept. So, I'll walk you through some ML concepts. We will experiment with tools a little bit to see if that is something that we can use in our hack the next time. And then we have part two, and part two is on 11th February. Let me also share the time with you. So right now it's 3 p.m. EST when we have this session, and for the next session we have, if I remember correctly, on Sunday. Yes, so I have a session at 7 a.m. Eastern. Whoa, it's a little too early for Eastern folks, but I hope you all can still join. Yes, so we have 11th February, 7 a.m. To 9 a.m. Eastern, the part two of the session, in which we'll talk about the ML algorithms. We'll talk about one like in general, which we'll be using in building the ML project. But there are so many algorithms out there. We'll touch base a little bit today, but in that session, we'll deep dive into that one and see how you can use that to build a project. Awesome. Everyone, still with me? All good? Does this plan sound good to you? Put that in the comment section if that sounds good to you, that's something you are excited about, and if what I have in store for you works for everyone. All right, let's see some comments. Sounds good. Yes, awesome, excited, great. Put that in the comment section if you're excited for the session as much as I am. The energy should be high because that's how we're gonna do. We have a lot to cover, right? So if the excitement is gonna be high, that's how we're gonna achieve all of our goals. Awesome, let's get going. Amazing, perfect. All right, so diving right into it. First up, now things would start to gear up from this point. So what I would recommend is that you have your notebook or an untitled doc open up where you can type in some notes. If there's anything that you think you didn't get quietly, don't be afraid to ask questions. Just put that in the comment section and I'll be answering questions throughout. Another tip that I have for you is that try to keep taking notes. And if there is something that you sort of got the vibe of, but would want to explore further, put that in your notes and then go ahead and revisit. That's how you'll continue your learning process. And that's how you will take a good chunk of information home. I promise you that. All right, so what is machine learning? Now, you probably use it many times a day without even knowing. Let me put that out there because there are already a lot of applications that are in use with this. And then let's brainstorm a little bit so that we can set base. All right, so for those of you who don't know, like, let me give you an example and paint you a picture. Now, say anyone you want to upload pictures on Instagram or Snapchat, or if you've used Google Photos here before, then you would have seen that Google Photos sort of labels your photos based on faces. They can recognize faces of you, your friends, and then categorize your pictures according to that. Now, that is one use case where you are able to see, let's say it's your friend's birthday coming up and you want to post a picture on Instagram for their birthday. Now, it's very easy to go into Google Photos, click on the a person's face and then go through the pictures and then find the right one, right? And that is something that uses ML technology to sort and categorize pictures into the right category. So that's one. Okay. So sorry, quick question. I see a comment here that you can't see the video or the presentation. Is that correct? Everyone else, can you see it? See me fine? Can you hear me perfectly? And see the presentation? Perfect. So everyone else can see it. So Mandy, I would recommend you join in again on the chat because I think everything is fine from our side. All right. So continuing. All right. So that's one example. But there are tons of other examples that we can discuss. Like let's say you finished watching. Okay, give me some examples. Say what's your favorite movie? Put that in the comment section. Everyone, what's your favorite movie? Give me a favorite movie of yours or a series or perhaps a movie that has multiple parts. All right, so let's see what we have here. So we have John Wick, Interstellar, Hangover, Three Idiots, Batman. Wow. I love I've not seen Interstellar yet, but I love Hangover, I love Three Idiots. Batman is an all-time favorite. I've seen John Wick too, I think. I still need to see Interstellar. I've heard great things about it. Awesome. We are deviating from the topic. But all right. So you see that there are a lot of favorite movies that you have. Now, I also see Mission Impossible. Great example. So let's take that. So let's say you finished watching Mission Impossible. After that, if you're watching it on Netflix or in some similar platforms, then you'd be able to see some recommendations of similar movies. Let's say you'll be able to see Mission Impossible Part 2, Part 3, or you can also see some similar movies, some spy related movies or something else like that. Now, that also uses ML. So you can actually do build a movie recommendation system with this technology. So there are tons of applications. Uh, Awesome. All right. Okay. So, some of the most interesting things that you can think of. Let's see. Uh, yeah. I think some of the most advanced topics can be if you wanted to recognize human speech, you wanted to diagnose diseases from X-rays, or self-driving car. How can we forget that? Applications are endless, is what I'm trying to say. So, can you think of a few more examples like that which you've seen around in your day-to-day life that have used this technology before? Put that in the comment section as well. Love to hear from you. So, okay, I still see the movies are still going. Interstellar is a must watch. Okay, for sure. Yeah, I'll watch that. Okay, great. Yes, definitely. So put that in. Can you think of any ideas from your day to day? Anything that pops out? Gen AI, definitely. So right now, I think if you use some your email, you'd be able to type in your email, and then with the press of a tab, you can finish your sentence. I think that's one of my favorite technology, like favorite use of this technology. I think it's so easy to get things done. Chat GPT, all right, recognition tasks, computer vision, perfect, great examples, absolutely. So what is machine learning? From all of this, let's boil it down to something that Arthur Samuel has said here, that machine learning is the field of study that gives computers the ability to learn without being explicitly programmed. So we don't explicitly tell the computer to sort pictures based on someone's face, right? We don't give the face in advance. The machine learning algorithm learns and relearns itself, and then that's how it categorizes that information. Similarly, for the movie example, we don't explicitly program it to say that, okay, if this is the movie, then this is what the recommendations should look like. That is something that a model learns and relearns, right? I see some other examples: Copilot, speech recognition. Yes, definitely. So there are tons and tons of great examples. So at its core, machine learning is all about creating and implementing algorithms that facilitate these decisions and then make predictions according to that. Right? So these algorithms are designed to improve performance, optimize over time. They can be more accurate, more effective as they process more data. So if you want a computer to, let's say, recognize images of dogs, right? I love dogs. I'm not sure if you're a dog person as well. If you are, put that in the comment section. I would love to hear from you. If you're a cat person, then put that in the comment section too. So yeah, I mean, I love dogs. So let's talk about that. So let's say you want to you have thousands and thousands of images of animals, and you want to recognize the images of dogs in this case. So what we do is we don't provide them specific instructions on what a dog looks like. Instead, we give it thousands of images of dogs and let the algorithm figure out the common patterns and features that resembles a dog. Over time, this algorithm can process more images, it gets better at recognizing dogs, and even when we are presenting these images that which it has never seen before, that point it can actually uh, based on the training data that we provided, can find an answer for those images. Now it can say, let's say that algorithm just does just two things, right? It says that if it's a dog or it isn't. So at that point, if you provide a picture of a let's say a cat, then at that point the algorithm would say that it's not a dog. That's it, that's simple. But based on the training data that it knows what a dog looks like, it recognizes the correct patterns, and that's how it makes a decision. So as you see, it's not being explicitly programmed, but it has the ability to learn through it. More of a cat person. Four dogs, big dogs, love animals. Awesome. Okay. All right. We have someone who loves penguins. Oh, that's so great. It's so great. More of a cat person. We also have someone who loves lion. I mean, definitely go for it. I don't think that that can be a house pet though, but good choice. Good choice. Interesting choice. All right. Good question. So, what happens when there are no good inputs data but clear mappings and associations? Can ML systems still learn? So, this is where an important discussion opens up. There are a lot of research papers that talk about how data is absolutely important, an important aspect from when we are working with machine learning models. If your data is not, let's say, you're not providing enough information, and we'll also talk about something called underfitting and overfitting later in this presentation. But if your data isn't good enough for a model to learn, then it also can lead to errors. That means that the accuracy of model is hampered. With that being said, that doesn't mean that it won't always give you, like, it'll always give you a wrong answer and it'll never give you a right answer, but the accuracy still goes down if there are no good inputs, for the training data. At least this isn't still 100%, but it's still very close to it, so you might always get a right answer all the time. But here is where the trick lies. We've been seeing around examples of how ML and AI is being used around an application. But at the end of the day, it's we as humans who make a decision when we see something, right? So if you see an answer and you know for sure that it's wrong, that's absolutely fine. The model is still learning and it's an entire process. So you can see how you can optimize that further. You can make a decision there whether that is the correct answer or not, or if it's a one off error. But yeah, ML systems can still learn, to answer your second question about that. All right. Okay. Awesome. All right. Moving on. Now, there was a question that was being asked in the chat, so I'm going to answer that right now and settle the debate. The question was, what's the difference between ML, AI? And I know some of you didn't ask it, but there are questions about deep learning as well. There's data science as a question. So there's a lot of terms that are going around. So let's settle the debate and then talk about briefly on what these in terms actually mean. So first, the AI part. So sorry. AI refers to the development of programs. So, as the diagram, I don't know if you can see the diagram clearly because it's very short, but no worries. I will explain it to you. Just give me 1 second. I feel like I've been talking for a while. All right. So, artificial intelligence, we were talking about that. So it's the program, it's the program's ability to actually learn and react, like reason like humans. We develop a program that can behave intelligently, mimic human decisions, and then through like human intelligence and through a set of algorithms that we define. Now this particular field focus on three different things. One is that it learns through the models. Second thing, it reasons and tries to mimic what a human brain does, and then it self corrects to obtain the maximum possible efficiency and optimize to it. Now, this can either refer to a machine learning based model or can also be an explicitly programmed computer program. So, AI is a very broad field. Now, the second part of this would be ML. Now, ML would be a subset of AI. Now, as we discussed, that AI can refer to either a machine learning based program or an explicitly programmed explicitly programmed computer algorithm. But machine learning is a subset of AI. Now this use what this does is it uses algorithms to learn from data and then make predictions. It can classify it, it can cluster it, which brings us to some types of machine learning, which we'll talk about shortly. But yes, there are supervised learning, unsupervised learning. They can learn through patterns, it can discover general patterns and then cluster it together. It can predict numerical values on historical data and then categorize events based on certain labels. It can say true or false, etc. So there are tons of things, tons of applications that we'll see shortly with machine learning, and we'll talk about the different types of machine learning as well. But this is where it just learns data and then makes predictions from it. Deep learning, on the other hand, is a subfield of machine learning too. It's based on something called a multi-layered artificial neural network. Now, this is also some place where it is inspired by the structure of human being, but in this particular subset, we learn from large data sets. So we feed it large sets, and then we like ask it to make like based on some assumptions, we ask it to make some decisions and then give us that. Machine learning, where we're making predictions, here we're doing a little more than that. And then there is data science. So for this data science aspect, let's think of it this way. It works across all. It is not specific to one particular technology at this point. And what it means is that it seeks all of this data and then studies the value that it gives. So I know that I'm not sure if you've learned of this the same way, but there was this one point in my school where I did learn that there is, if you can have like a lot of data, but at the same time if you cannot output any value for it, it doesn't become information. So if you want information out of data, that's when you have to learn the science, make decisions, understand how to categorize it, how to define what it means, how to put it in a way that is easily readable, accessible for folks to understand. And then that's how a lot of this information about graphs come into play, right? When you use that, it gives you an idea of what's happening in a single glance. So there are a lot of things that go behind it. If you want to extract value from data, that's where data science comes into picture. Okay, all right. So question: if we have small amount of data, can the model still be trained? The model can still be trained, but the model's accuracy might not be high, because at this point it will have very small amount of data to base its decisions off on. And so that's where the error rate is high. Mm, okay, cool, awesome. All right, sorry if I've missed your questions, but feel free to post them in again. uh okay, all right, moving on to some details. Now, this can be a whole separate session to go if we go into nitty-gritty details, but let's talk about how machine learning works in general. So here we're talking about building a machine learning project. So we'll talk about how we're going to build this, right? And this is based on my research as well. So as I said, this entire session is for me to tell you how my research process works. So this is something that I found with a few clicks here and there, researching on Google, and then figuring out what it means. So I just thought that getting started would be easier, but this is my way of explaining things to you. So first things first, in this session we will learn how this machine learning things work, and then in the next session when we actually build that project, we'll try to relate it through these steps. All right, sounds good? Well, the tools we use will be free. Okay, so some tools that I'm going to share today are free to use, but there are other tools as well that are paid. Some of them you can get credits for if you're a student, some of them are just paid in general. But don't worry, for the purpose of this session, the tools that we're going to use are free to use. They're open sourced, and you'll be working with free tools. And you also don't need to download or install anything as of now. I found this amazing website where you can use this online on your browser. Cool, awesome. All right, moving on. So talking about machine learning. So how machine learning works and delving into the step-by-step process. So there are a lot of things that we need to do. We have raw data, like from raw data to valuable insights. It's a long journey, and you can see that on screen. But I know that it's a lot of information. Let me put this like this. So I know you can't see me, but I hope you can still hear me. I just wanted this to be like the main screen so that you can zoom in and out and then navigate through it. This is an amazing picture that I found from DataCamp, which describes this entire process diligently. So let's break down the process and spend some time on this slide. The first step, which is data collection, it's very important. I know someone asked this question, so I'm going to try my best to answer it right now. The first step in machine learning process is data collection. Data, this is the main value that we get in machine learning. This is the main input that we are providing. The quantity and quality of your data can impact your model's performance. It can surely do. And it can come from various sources, whether it's databases, files, images, from the web, anywhere. You can do something completely out of blue and then create your own data set as well. I know we tried to do that when we were working on a thesis project. Not as easy as it sounds, but you can still do it. But then it can come from various sources. And once collected, once you have that data that you need to prepare for the machine learning model, next the process comes in for organizing the data into suitable format. So it can either be into a database, as I said, or in a CSV file or some other format, but you have to ensure that the data is relevant to the problem you're trying to solve. It's very important. And I remember in this one session I had in a hackathon that I went recently, where they were talking about how you have to know what is the right question that you're asking when working with AI ML models, because that's how you will distinguish and base off all of your decisions. So put on a clearer problem statement and then find the right data. And then the next step is data pre-processing. Data pre-processing is a crucial step. It involves cleaning the data, removing any duplicates you have, checking for any errors, handling missing data to see if there is any missing information. Let's say you have you're collecting height data and you have all of the information, but the height wouldn't make sense, right? So you can remove some entries if it has missing data. You can fill it in if you know the right answer. And the third step would be normalizing that data, scaling the data to a standard format. Data can come in all sorts and forms. So let's say you are collecting data for dogs who are vaccinated. We love the dog example at this point. So let's say we are collecting data for dogs who are vaccinated. So we have dogs, we have the date of vaccination, and we have what vaccination was done. So at this point, there are three different things. Then there can be a point where there are missing entries. There can be a point where there are missing columns, and then you need to make sure that your data is corrected. So that is what comes in data pre-processing. It involves improving the quality of your data so that the machine learning model can interpret things. And this significantly improves the accuracy of your model. Good thing for us, there are already some data sets in store that you can use. I know there's this one. I know of this one website. I'm not sure if you know of it, but Kaggle is another website where you can get data sets from. There are some additional websites as well. There are some libraries that give you some general data sets that you can use if you're just working on models and all you need is a data set to perform some actions. It can give you example data set and then you can base your work off of it. Okay, so next comes choosing the right model. That's the other step. And this is the process where now we talked about project setup, we talked about data preparation. Now we are in the modeling state. So in modeling, we want to choose the right model, right? So we want to make sure that once our data is prepared, we know what our problem statement is, know what types to choose from, and then make the right choice. We have a lot of options here. We have linear regression, decision trees, neural networks, and the choice of model actually depends on the nature of your data, the problem you're trying to solve, as I said. So there are a lot of factors that you have to consider. Maybe the size of data is too large. Maybe okay, let me come here. All right, you can still see me and you can still see the slide. Perfect. I figured out another setting. Oh, all right. Yes, the slides would be shared to answer your question. I came back to answer questions, but anyways, got distracted. All right, talking about modeling. So at this point, yes, you have to train your models, and in order to train those models, we were talking about how you have to choose the right model. So your size can be too large, your type can be different, and then all of this, the complexity of the problem is also another thing that you have to think about. So a lot of things go into making that decision. And then we will talk about shortly about what types of machine learning models exist, and that would make a little bit like your life a little bit easier. You can then make a choice on a little, like some, for some basic examples, you can make a choice on which model to use, but then which model to use for which problem, that's a whole separate conversation that we can get into, but we'll not go into right now. So training the model. Now, after, let's say you've chosen the model that you need to use, the next step is to train it on the prepared data. You have all the tools now. You know which model to use. You have prepared your data, and now it's time to feed it the training data so that it can learn from it, understand its parameters, and then make it predict the output later. So this is where I want to talk about very specific. There are two different things that can happen in training that often compromises the accuracy of the model. First one would be overfitting. Now, this is where the models can perform well on training data, but when you give it a test data, it fails miserably. And this is where you fit the model perfectly on the training data. You gave it certain examples of like perfect dog pictures, but as soon as it saw a blurry picture, it just lost it. It couldn't make a decision at that point. So it's important that your data has something from all aspects. So your training data and your test data should have equal number of examples for the model to learn from. Then there is also the case of underfitting, where your model can perform poorly on both the training data and new data. And that's where we say that if like the model doesn't have enough information to go off on, you need to supply it more examples for it to train and then increase its accuracy. So a lot of this is an entire process. And you can see that in this case, you have a lot of steps that you are constantly going through over and over again. So all of the previous steps had like one step, two step, three. This one is a circular motion where you have to keep doing this and then making the right decision. Okay, sorry. Questions. Let's see. It seems like the process to create machine learning end-to-end system is big. Like you prepare clean data, modeling data, deploying the model. The workflow is huge. By taking this workflow into consideration, working as a team is the best way to go. Absolutely, it is. But here's a tip. We are learning the entire workflow so that it becomes easier for us to focus on the most important aspect. We would be focused totally on data modeling at in some time when we talk about that. But the data preparation, project setup, if there's a specific use case, you can train your model according to it. um, Another thing to note here is that as I said, some of these websites already offer you pre-processed data, so you can use that data to like train your model and then feed it test data later on. So there's always example like that. Okay, all right. So evaluating model in now next comes the E part where we are evaluating the model. That's where we focus on deployment, we focus on performance, we focus on all of sorts of things. So now we want to evaluate the performance before we deploy it, right? This involves testing the model. So another thing that is important here is that whenever you, let's say, get data from one of these websites, you have a large data set divided into two parts. Have testing data separately, have training data separately. Once the model is trained on the training data, use the testing data to check if the model learned something, like is behaving as you want it to behave. If there's new data that it hasn't seen in training, what it does based on that. So there are a lot of different cases that you can go through, right? And some of the metrics that you can use to evaluate the model, which we will do as well in our ML project, is accuracy, for example. So for classification problem, it's very important to check the accuracy of your model's performance. And there are tools again that you can use to check the accuracy of your model, which we'll talk about shortly as well. You can check precision, you can check for some mean square errors, anything else. So there's tons and tons of ways that you can check for a model's performance. For different models, different metrics come into picture, but it's very important to evaluate the model that you have used. And once you have evaluated it, that is when you can adjust it, tune it, optimize it if you want. Once it works fine for a certain set, that's when you optimize and increase the accuracy. So you keep on training the model with that can be with more data. You can do different combinations of different parameters, tweak it a little. You can divide the data, as I said, into different subsets and then perform actions on them. So yeah, lot of things that you can do, lot of crux here, but we'll not go deep into it because, as I said, there are some tools that do this for you and help you out with it, which we'll be using. Next up is predictions and deployment. So once it is trained, optimized, and you're happy with it, that's when it's ready to make predictions on new data. And this is when the process comes in for decision, like model making decisions, and then you doing further analysis to improve it. Deploying involves a whole separate thing which is called ML ops, and then that is when you can work with real time data that is not pre-processed like your training data that we did. It can be very messy, and it's very difficult for the model to base off its judgments on that. So in real world data, your model might not perform as well. So you keep on improving that, and then you provide real time insights once your model is trained at an app level. So you see, there is a lot that goes into this workflow. We spent a good amount of time to understand this. I hope this makes sense. So let me see if you have any questions meanwhile. All right. Okay, I answered these questions. What proportion of data set must we have as testing data, and how does one decide which data goes into testing and which goes for training the model? All right, so if you are picking up a training model that is like an example training model, as I said, from Kaggle or anywhere else, there would always be instructions on how you can divide it into training and test. But if there isn't, you can put pick a random number and do half enough. If your model doesn't work correctly, you can introduce more images into that data set and then divide it based on your own areas. The thing that we want to make sure is that the model has examples to train, and then it has examples to test as well. There should be some images in test where the model has which model has seen before, to see how it predicts unpredictables, like how it predicts in situations that it hasn't viewed before. But again, this is where we strike a balance. All right. Okay. Any questions on how this entire workflow works? But anyways, if you have any questions, put them in the comment section. Love to help you out answer that. Okay. So, all right, great question. How do you correct overfitting or underfitting? Very good question. So, as you see that a model can have a lot of, you know, situations where there would be cases of overfitting. So let's talk about that for a bit. Overfitting, as I said, is a situation, for those of you who missed it a bit. Overfitting is a situation where the models are performing well on your training data, but performing absolutely poorly on new data. The reason that it happens is that the model seem to be in a situation where it has seen a lot of information of similar type of pictures, but with new data it doesn't seem to be performing well, doesn't give you the right answers. Some of the ways that you can do this, you can prevent overfitting, is by stopping early. It's by making sure your data is augmented in a way. If you have several features or several images of the same photo, like a same image, then it's important to clean your data in a way that it's pruned. All of this falls upon the data pre-processing and cleaning part, where you can work with your images and then see what needs to be tweaked in order to make the model fit better. And yeah, so and with underfitting, of course, underfitting is a way where you can you need to add more layers or more examples to your network. You need to supply enough parameters to your model for it to make a decision on. Let's say it's an algorithm where you're just basing your decisions off of one parameter that it has and knows, it might not make enough decisions, right? And that's just an example I'm giving you. So you need to increase the parameters a bit, and that comes in ML algorithms. So that's another way of helping you. All right, cool. Okay. Let me. Oops. Perfect. All right, we're back in the same layout. Okay, so yeah, we talked about how machine learning models work, how the entire workflow is, and now we will dive into the types of machine learning models, and some types of machine learning that you can do, and how you can use these different algorithms to make decisions. So there are three examples that I have up on screen. Not examples, three different types that I have up on screen. So in these three types, these are just broad classifications, and there are sub classifications as well. But the data is when the data is available and you want to train, you want to understand the nature of how your data is going to be trained. This is where you make a decision on which type to use. There's supervised learning, there's unsupervised learning, and then there's reinforcement learning. So supervised learning, the most common type of machine learning approach, and I think when you're starting out, this is something that you will be using a lot. Now this model is trained on a labeled data set. What I mean by that is, we talked about cats and dogs examples. That's clear labels, right? There's cats, there's dogs, and you can also put in a label for not a cat nor a dog. So all of these three, like three different labels that you've provided to your algorithm, so it can basically categorize all of the images into these three sets. This is labeled data set. Let's say you want your data set to just tell you true or false or something like that. Again, you just give it some input pictures, and then what you want to do is you want to get an output label during this process. Let's say you are categorizing fruits: apples, cherries, bananas, etc. Again, label, you put a label, output label on that process. So in this point, there are two different things that you give your model. One is the input, the features, and then you give it the output, the label, right? And this data is accompanied actually has that label which the model is trying to predict. So you give that information to the model, and then what it does, it can categorize it into different uh, and classify into different categories. So yeah, sorry, I lost my train of thought in a bit. So as I was saying, with supervised learning, there are different algorithms that you can work with. There can be linear regression that solves regression problems. There is decision trees, which is basically based upon certain factors. If this is a yes, then it makes this decision. This is a no, it makes that decision, etc. And it can go on and on with that. There is classification problems where you can reuse the classification algorithms. And we saw the cat and dog example, right? So that is a good example of how we can categorize images accurately through a supervised learning model. Then comes the unsupervised learning model. In this case, it involves using a training data on an unlabeled data set. So the first one had a labeled data set. This one we're not so sure about, and it's upon the model. It's onto the model to actually find patterns and then put them into different clusters, right? So this is again, there is an algorithm called k-means clustering. For k-means for clustering problems that you can use. There is PCA as a model that you can use. There are different models here and examples of what supervised learning algorithms look like. But to give you a good example here would be, let's say you want to understand some purchasing of your product. Like, let's say your product is being purchased by a lot of folks, and you want to understand which part of the world has the most sale for your product, etc. And you want to understand the demographics, you want to understand the sale, you want to understand some metrics, and you want to base your decisions off on where to increase sales, where to put most effort in, etc. There's a lot of things that go around. Now here you're really not sure what you're looking for. You have data, but you're not sure what the data is going to give you. You want to understand what it's going to look like. You don't have labels, perhaps. So this is where the unsupervised model would put them into clusters, whichever makes sense. They would like, what it will do is it will recognize patterns that are common, and based on those common patterns, it would cluster it into one category, and then feed like when once you have a return answer for it, you will be able to see what that cluster looks like. Okay, right. Come, just I'm gonna quickly shift back to the screen to see if there are any questions. Okay, perfect, awesome. I can see that everybody is doing fine. Great. Quick vibe check, everyone. Put that in the comment section if you're doing well. If at this point you are still with me and you have a little understanding at least of all of these models. Even if you don't know the names of the models or algorithms, that's fine. But if you understand the concepts, that's the main thing that you're gonna take home. Still here, doing well, awesome. Like, give me a high five or a cheers in the comment section if you are doing good, if you everything is perfect here. Okay, perfect, going great, alive, awesome, energetic, not just alive, we need to be energetic. Great. All right, so now we talked about supervised learning. I talked where there can be classification and regression and its types. We talked about unsupervised learning, where the clustering is a main aspect of it. Then we talk about reinforcement learning, another important type of machine learning algorithm. Now the this is where it your model actually learns to make decisions by interacting with its environment. And when I say that, what I mean, it gets rewarded or gets penalized based on the action it takes. So its goal is to actually maximize on the total reward. Let me give you an example. I know this was just a lot of words and might not make sense, but it will. Just give me a minute. Stay with me. All right. So think about this in a way. For example, let's say you have an ML model that plays chess, right? Now, playing chess, it has different types of ways, or what do you put this? Different moves that you can make in order to win a game of chess, right? So Yes, absolutely. Let's go. Let's keep reinforcing this. All right. So, we were talking about chess, right? So, in chess, the computer doesn't know what move you're going to play, right? And it has to base its decisions based on your move. Now, in this case, there is no right or wrong answer. There are no labels, there are no clustering, there are no categories on whether a move is definitely going to make you win or lose. But it definitely can reinforce its learning, figure out that, okay, based on this move, if I make this move and the other person makes this move, there is a chance of winning. And it can predict the percentage of winning. So it can be rewarded for a decision well made. It can be uh, penalized for a decision that it isn't good. And so a great example is game playing of reinforcement learning, where you need these algorithms to predict future outcomes. But in this case, the only problem is that the data should be sequential. That in chess, this was the move that was played, this was the move that was played after, this was the move that came after that. So this was the final learning process. It's sort of like, in my head, it's sort of like a step by step process of moves, but reinforcement learning bases its decisions off of that. So it interacts with the environment, then see what's the result is, and then gets rewarded or penalized, and then predicts an accuracy score. So that's a very good example of reinforcement learning. Another thing is resource management. Another thing is capacity planning. There are tons of ways, as you can see, for this part. All right, coming back to the stream to see, quick check. All right, so everybody's doing fine. All right, perfect. Let's move on. Now, we understand the process, we understand the types, and now I talk about the tools, the important stuff that's going to help us build these things and bring it to life. So, how do we build ML models is the great question. First off, let's start with some programming languages. Now, there are popular programming languages. You can build ML models with a lot of languages, but some of the popular ones are Python or R. Python is another is a programming language that you can use because it's simple to use, easy to learn, and it's honestly a great choice for beginners. I love Python because it has a strong ecosystem of libraries and it is very tailored for machine learning. And there are great libraries. For example, there's NumPy, there is Pandas, and there is also PyTorch. Some of the other tools I'll also talk about. For example, scikit-learn, TensorFlow. I know, not of words. Don't worry. We will talk about them. Like, for example, NumPy and Pandas is used for data manipulation. We also have Matplotlib, which is used for data visualization. You can build charts and stuff. There's Scikit that provides machine learning algorithms, and then there is TensorFlow and PyTorch that is also used for building and training neural networks. Similarly, for R, there are different libraries that you can use, different packages that you can use, and it's very great for regression and classification algorithms. It also has that rich ecosystem, but it is mostly for a statistical analysis that you use it. So a lot of companies defer to R at this point for those sort of models, but a lot of companies, and Python is still the popular choice in most cases. Oh, okay. So now tools. Some of the tools are mentioned on screen, and I would like to go through them a little bit uh, one by one. All right, Python, go Python, great. We have a lot of Python lovers in the chat. Love to see it. Okay, talking about TensorFlow. Now, TensorFlow is a library that you can use for computation purposes. It is suited for machine learning, and this is something that is supported by the Google Brain team. So you can build and train complex neural networks on this with TensorFlow, and it is mostly used for deep learning models. So you can feed it a very large data set and then make predictions, make decisions based on that, form actions on that. There, TensorFlow has a very wide range of services that it offers. Then comes scikit-learn. Scikit-learn is again a Python library that has some wide range of machine learning algorithms that is suited for your needs. If you're building a project, you might want to check into scikit-learn because it has some of the most amazing algorithms and very easy to use as well. You can provide it parameters. There's very clear documentation to start with. And quick tip, we will be using this in the next presentation in part 2 of this session, where we will use scikit-learn to make a model. So hear this one carefully. There's a lot that it offers. And the reason that it's easy to use is why it's being adopted so easily everywhere around. Some of the other benefits that you would see would be classification, regression, and clustering algorithms. It's very easy to do in scikit-learn. All right. And it also works very well with your Python libraries. So you can see it's a clear choice where you can, this tool is free to use and it's going to be very helpful for you to work through your ML models. There is also Keras, which is a networks API that you can use, which is running on top of TensorFlow. It also helps you train neural networks. And then there's PyTorch as an example. Again, another great machine learning library that works very well with Python. And it can help you work on computer vision or natural language processing related models. So all of this, I know, a lot of information, but these different things are just tools that you can use for different purposes. Cool. All right. And then matplotlib. I actually really, really love this because matplotlib is for data visualization, as I said. So this is something that you use when you want to display the results of your data, or let's say you want your you have a huge data set and you want to see what the general trend of your data looks like based on its points. And so matplotlib helps you visualize that perfectly fine. Okay, great. Question time. Okay, see a lot of examples, great examples of things, of tools that you can use. Okay, great. Okay, we have a question, but it's always the right time for questions. Don't worry about that. How do you correctly prepare a .csv file for upload? Okay, so in this case, we talked about data processing, right? So I'm just going to answer this very briefly because this is like a huge topic. So the brief answer for this is that preparing your data, if you're doing it on your own, then you have to be very particular in making sure that there is no missing data, there is no information that the incorrect information, or it has enough. The more you can feed your model enough information as well. That's another one of the things that we talked about. So if you're preparing your data on your own and you are cleaning up your data, then that's how you do it. But these are some of the things that you need to take care of based on the use case that you're working with. This can change very, like, this can be very different in terms of how you prepare your data. And again, there are other tools that you can use, and some of these have some examples in for data processing as well, which you can use. Okay, good question. Can I watch this later? I have to go to college. Of course, this will be recorded, and we 1 hour into the session. We still have another hour to go, where we'll try out some technologies. But you got the core concepts, and I'm proud of you for sticking through it all. So go attend your classes, and this session would be live recorded. You can rewatch this later. Okay, awesome. All right, so Matplotlib, as I said, I love this, and what I'm going to do now is that with the rest of the time that we have, we will try this particular library because I think this is going to be really helpful with a lot of your models. With the other examples, it depends on your use case, on what you use, how you use it, what project you're building it for. But Matplotlib is just versatile across anything that you're working with. You want a data visualization tool to help you do that, right? So this is something which is going to help you. And all right, so we will move right into some demos. Let's make this work. Hold on, let me stop my screen share and then share again with the tool that I'm going to use. Again, I'm going to share this with you as well, so don't worry. This is absolutely incredible. I just stumbled upon this, but it's great. Okay, so this is a tool called Jupyter Lite, which is like a Jupyter lab, which you can use to work your ML models. You can type in Python scripts here. Let's say x equals to a, x equals to 10, and then we do a print x. It works perfectly fine. There you go. See? I'm just going to delete that because we don't need it. It was just showing you how this looks like. But let me share this link with you. Hold on. Oh, you don't see my screen? Sorry. Hold on. Let me try this again. Nothing happened. Nothing to worry about. We'll do this one more time. X equals to 10. You do a print x and just typing in a bit of Python, and you can see this works absolutely fine. You can do a lot of things with this notebook, but again, it's your to use. So let me share this link with you, and I'll also put this up as a banner so you can view this. There you go. Quick link. Perfect. All right. Okay, so this is something that you can use. This is amazing because you don't have to download Python or Matplotlib or anything else. Like, for example, we'll be using Matplotlib, so you don't need to download Matplotlib to use it, right? This is something that you can use to import the library from here. This is an environment that it gives you on your browser. Cool. Awesome. All right. Okay. So let me go back to the screen. All right. So what I'm going to do is because I have two different screens here, so I'm just going to navigate back and forth. So if you have questions, don't worry, post them in. I'll come back, I'll view it, I'll answer it. And let us try using matplotlib now. Okay. All right. So something that you should let's start with just something basic, right? We want to plot a line. That's all we're going to do. Very basic. So what we want to do is we want to have a library from matplotlib. That's our library. And what we want to do is we want to import pyplot. So everyone, I want you to do this with me because we are learning through this. We will be trying a few things and we will be trying what matplotlib offers and how this functionality can help us. All right. So what did you choose? I chose Python. Python biodide. I think that's it. So when you go on Jupyter, when you go on the link that I shared, uh, you can just create a new file from this blue button, and you'll be able to see something very similar. Um, can you still see me? Sorry, my bad. Some technical difficulties, folks. Don't worry, I am back. Nothing to worry about. You can still see me. Perfect. Still see me? Perfect. All right. Awesome. Yes, we are back. Don't worry. Don't worry. It was just a very tiny small hiccup. Technical difficulties happen all the time. Don't worry about it. Let me see if you can see my screen. Let me put this up again. All right. Selected Python. Okay. So you click on this plus button and then you can select Python Biodide notebook. Cool. And this will open up the notebook. Everyone with me? All good? So you just click on the plus sign, select Python Biodide notebook. Perfect. Perfect. Everyone? Put that in the comment section, folks. I want to hear from you. If everything is good, we will move on. We will help everyone stay on track. We're in this together. Come on. Okay, awesome. All right. So, and now what we're going to do is we're just going to plot a line. So I want you to type this with me. If you can't see my screen, let me just zoom in a bit. Can you see it now? I don't know if I can do this, but let me know if you can see this clearly now. All good? Perfect? Great. So, quick recap of what we do, what we're doing here. We are using matplotlib, and what we do is we'll plot a line. So I put a comment hashtag. That's how we put comments in Python. So we put a comment line, and then from matplotlib, I import pyplot. Pyplot is what we're going to use to plot the line. Cool. Everybody on the same page. Perfect. Great. Okay, so from pyplotlib, you import pyplot from matplotlib. Type in that, and then I will just give it a name, a short name, so that I can use this easily. Cool. Nothing. I did nothing here. Everyone, no need to be worried about any of this. It's totally fine. What we did here is just imported the library. Got it? All good? Yes, we can do that as well. Okay. All right. Cool. Now, what we'll do here is just yes, we can do import matplotlib.pyplot as well. But the thing is, I just wanted to explain. So this is what we are doing. Oh, it's by after as it's just PLT, just a short form of what I am going to use. As is something that we use if we want to um, so I don't know, I'm not, so it actually works with different programming languages as well. I'm trying to explain it in a way that we don't want to use the entire pyplot dot thing. We'll use plt dot everywhere. Cool. All right. Okay, moving on. So what we have here is we have our plot. Now to plot a line, what we need the x-axis values. So let's just say x values, and the second thing that we would need is y values. Correct? Everyone with me? That's what you need, right? Basic things. in your with your line, you need an x coordinate and your y coordinate. So what we'll do is we'll feed it some x values and some y values. So let's say we have x equals to 5, and then let's have another value, say 2. Then we have 9. Give me some more numbers. How about 4? About 7. Perfect. Everyone good? You can put in any numbers you like. I'm just putting in random numbers at this point. So, and with the y coordinate, so remember, the x0 value and the y0 value is the xy coordinate. Does that make sense? So just to give you an idea, let me put in some y values first. So let's say this is 10, this is 5, let's have 8, let's have 4, let's have 2. All right, so we have different values here and values here. And what we want to do is we have x values, we have y values. So the x, just to give you an idea, x comma y for the first value would be 5 comma 10. Does that make sense? Cool. So it would plot 5 comma 10 on the line. Perfect. All right. Okay. Yes, that's the word I was looking for. Thank you, Belbloom. It's an alias. Okay, great. Perfect. No questions. Great. So far, everything is good. All right, so let's try it very simple. So we'll do a PLT dot. PLT is the same thing that we wrote here. Anything that you write, you can write anything here. It's an alias, as we said. Anything that you want. It can be Sashrika, Sashrika dot. Absolutely fine. And what you want to do is you want to plot this graph. So let's plot the x and y coordinates. Cool. Very easy. And honestly, you don't, I think it's in Python, you don't need semicolon. You can add it, but you don't need it. I just have a habit of writing Java code, and that's why it's on top of my head. But no worries. But with now you have PL plot x and y. You have the x and y values. All good here. Let us do a plt dot show. And so when we run this, we are able to see a graph, a a beautiful graph made out of the values that we inputted. Perfect. All right, so matplot, this is something that it's actually okay. Let me see if there is a question. Okay, good question. So hashtag xy510, what does it do? Nothing, absolutely nothing. That's a comment. So in Python you add comments with a hashtag. So that's why I have hashtag line to show that this is where we're going to plot a line. Hashtag x values, I wrote because I was writing x values. Hashtag xy 5 comma 10. This is just what it means when I was talking about coordinates. So the x coordinate and the y coordinate 5 comma 10 is the value that I inputted. So if you can see from the graph, let me scroll down a bit. The first value that we have here is 5 and then comma 10. This one. See? So it's being marked here as 5 comma 10. So I was just showing that these coordinates are, this is how we are inputted coordinates. There's an x-axis, x values and the y values like this. Cool. Everyone on the same page. All good? Perfect? How do we see the lines? The way that you see the lines is because we used a function with matplotlib, which is a plt plot. And then when I did a show, it printed it. Cool. I think everybody is on the same page. Everyone got it. Perfect. Feel free to type this. Yes, of course. It's very easy. I think someone also shared the code in chat, which is great. So your y values are less. You have 8, 10, 8, 9, and you have 5 x values and less number of y values. That's one thing that I notice. Yeah, rest everything looks fine. Cool. Awesome. Live debugging. Great. All right. So moving on. Let's talk about some of the other things as well. Now, you were able to plot a line at this point. Now, let's say you wanted to plot a bar graph. So this is something we will do now. We will plot a bar graph. So we had PLT and we wanted to print a bar. with x and y coordinates. Bar, sorry, typing speed is getting low because I was navigating between spaces. I'm on the same page now. So what we'll do is we'll use a dot bar. And then again, when once we do this, this will, if we run this, it will absolutely do nothing because we haven't told it to print it yet. So if we do a show, that's when it will print. There you see, a lovely bar graph based on the values that we gave it. How do you get the arrow after hash xy? I just typed it. That's nothing new on that front. Cool. Awesome. So this is how we can use a bar graph. Another thing that you can do now, everyone, look alive, pick up pace, because I think now we got the gist of how matplotlib works. We will just try out some of the other features it has, but this would be very quick. All right, everyone, stay with me. Perfect. So we were able to try a bar graph, but what if you wanted the bar to be horizontal? You can do a plt dot bar h x comma y, and then again do a plt dot show. And if we run this, you see a horizontal bar graph. But let's say you didn't want a horizontal bar graph or a vertical bar graph, you wanted a histogram. That is also an option that is given by matplotlib. Very easy. So you have a histogram, and then you have all the y coordinates. So histogram only takes one side of the coordinates because on the other side of coordinates it just maps it across. And it, so I'm not going to go deep into explaining how the histogram works, but let's show you the graph and you'll make more sense. So as you can see, it has values mapped shortly, and then here is where it plots all of the values together. Okay, so now if you wanted something to scatter, so let's do plt dot scatter. Scatter is just the dots, you don't want the lines, right? So we give it x and y, and we do plt dot show. Don't worry, I'll revisit it later if you're not able to type quickly, but just to go through a bunch of stuff together. Reviewing this, what we did was we had imported the library, we had the x values with the y values, we did a plt plot for line graph, and then show. Every time you do something, you plot it, and then you do a show. Um, that's when it prints it. Now, another thing to note here is that this is something that you like. I am using the same pyplot. uh, I'm using the plot to actually use the same values, and I'm showing you how it looks for different graphs, so you can pick your visualization. And that's why I'd say that this tool is actually versatile, because any project that you do, you would want to actually view the data at the end of the day. And so this is something that's going to help you. The project that we're going to build in the second session, it would be a great tool because we would be visualizing a very large data set through this library. I know with very small values it feels like a very small thing, but with huge chunk, like a large display of values, say around 2000 values, if you're looking at, graphs are really important to help you visualize what the data looks like. Okay, awesome. All right. I think everyone is doing fine, and it's great to see that you're helping each other debug, which is amazing. So keep at it. Okay, so quick check. Is everyone comfortable with what we talked about here? Very basic stuff. We talked about bar, we talked about horizontal bars, we talked about histograms, we talked about scatter, we talked about lines. 5 things. All good? Part 2 is 11th February. 11th February, we do it at 7 a.m. Eastern. Sunday. Perfect. All right, so everyone is good on the same page. This is what your scatter graphs look like. Now let's say what you wanted to do next was you wanted to you wanted to do a scatter. So here is where you can see those dots. Another way of doing scattered, and this is just some extra tidbit information that I'm giving you. If you wanted to do a line, let's say you already did that, but what you wanted to do was you wanted to not have lines, you wanted to have the scattered graph that we showed. But so you just do a dash. Oh, this is something that you call a marker, and something that you can use. A lot of people use this because it's easier to write, and you've already done it and you just want some change, make some changes, then it gives you the same result. But there's another different thing that you can try here, which is a marker. So I'm going to use that. So let's say you want to do a plt plot, and at this point you want to feed it the x and y values again. And then what you want to do is you want to do the same thing, but you want to use something called a marker, right? So a marker is, you can use the marker to emphasize each point and also have lines. So what we're doing here is we want to have the lines, we also want to have it marked, we want to have the dots on it as well. So let me show you how it looks like, because then I think it would be easier to understand. Plt dot show. There you go. So oops, did I do something wrong? Let me quickly check. X Y. Let me just copy it back again. I think it accidentally overwrote in the values, so I'm just gonna use that again. Oh, error. Da-da-da-da-da. Could not convert. Oh, sorry, string marker is missing, my bad. There you go. Oh, something else was also wrong. Oh, I believe this was not the issue. Hold on. Let me see what the entire code looks like. Matplotlib, pyplot, plt, we have the x and y values, and what we want is the x marker as 0. Things look fine. Plt show. Let me run this again. Oh, perfect. I think it just missed the, like, we might have overridden the x and y values somewhere. We were doing a lot of things. It should be marker equals to O. Perfect. It's the dash. Oh, might have missed it. Sorry. Yes, perfect. So here, yeah, I accidentally typed in the dash. Gone now. Let's see. Yes, plot's fine. All the values are here, and it also marks it. All right, moving on. So here are some of like the different ways that you can do that, but some of the other things that you can do is, let's say you wanted the line style to be dotted. So let's try doing that. I'm just going to copy this, come here, and then what I'm going to do is, instead of the marker, I want the line style to be dotted. Line style. Cool. So another great way if you want to like have something else. Again, these are just formatting at this point, but I just wanted to like show you some of the other things, small tips you can do. Because from what I understand, when you're working with these tools, you might not even know some of these features, and then becomes difficult to visualize things. So some of this nice little tips that you can do. All right, we'll move on a little bit fast because I think we are picking up pace now. So let's talk about pie charts as well, because I think you'll be using that for quite a long lot of things. So for pie chart, what you need is you want to have some labels. So this is very important. Now, the way, like, pay attention to this. The reason being because when you're doing classification with large sets, it's important that you have labels and then you put on the sizes right? And your model already does that. But let's say we have some fake data. So I'm just going to put something in. So we have student 1, and then we have student 2, and then we have student 3. Perfect. We have 3 labels and we have 3 different sizes. So our array for sizes, and you can, by the way, also use NumPy for array. I'm just using it directly from Python, but you can do other things as well if you want to randomize data. A lot of different tools that you can use, as I say. So yes, so we have 3 different students. I think here you can go ahead with single quotes as well. Not double quotes are not required. In Java it is, but sorry. I think with the different languages, the problem with me at least is just get confused between which syntax where. All right, so let's have some values. 35, 30, and then let's say student 3, how much is left? 35. So we've divided the 100% of the pie into 3 different students, and now we want to plot the pie. So very simple. What we're going to do is we're going to do plt pie, and then what we want to feed it is we want to feed it the labels and the sizes. Perfect. And then again, what we do, plt show. Easy. All right. So I hope you are all with me. I will give you just a little second to type all of this, but again, this is something that you want to do. Labels equals labels. just to make sure it gets mapped to the same thing. I just don't remember if in pi labels is first or size is second, so I'm just gonna put that right. Cool. So let's try this. If it, oh, positional keyword sizes goes first. Perfect. Knew it. There you go. Sizes. See, a lovely, beautiful pie chart that comes in right after this. Okay, awesome. All right, so some of the other things that you can do with pie charts, I'm going to copy this and then use it as reference. So we have the same data, but let's say you wanted to add a title. So we will say that we have plt dot title that you can use, and you can give your pie chart a title that student data. Perfect. Let's run this. There you go. It says student data. Simple. Small tips. Now we'll play around with the pie chart a little bit. Let's say you wanted to see the exact numbers here, right? So we have I'm just going to copy this again. We have 35%, 30%, and then 35%, and I want to see this. So what I'm going to do is I'm going to use something called auto PCT, which actually prints the values on top of it. So auto PCT. And so when we use this, what we want to feed it is we want to feed it how the value should look like. So this, in this case, it's a percentage float. So I'm just going to use that. And this float value is represented as in that format. So this is what I want it to look like. So I'm just going to map it to that, something that you can use. And then, as I said, this would be a float value. So remember, sorry, I think I missed a percentage sign. Perfect. So yes, if we go ahead and run this again, then I think we should be able to see. Perfect. Works fine. We are able to see the values as well. Now, what if you wanted to, okay, oh yes, there is another very great feature for pi that I remember, which is the start angle. I don't know if you've heard of it, but the start angle is something that you can use to define at what point you want the pie to start. Again, some of the formatting tips, but let's say we want to start it at 90. This is 90, this is 0, this is 180, and then 360. Like, you get the gist, 270. So that's the start angle. You want your angle to start at this point, you want the student one to start from here, and if we run this, it just neat pie graph, right? All right, so we did a lot of things, but there are some of the other great things that you can do. So what, let's say okay, let's try it with, actually we can use the same data, that is fine. Let's say we want to do an explode. Let's try that. I think that would be a good thing for you to learn. Okay, all right, so explode, let me teach you that. Okay, so let's say we want to do an explode. What an explode looks like is you just want the pie chart to pop out a little bit. You want one piece of your graph to highlight over the others, the one, let's say, which is the largest. If you want, in this case, we have 35%, but let's say you wanted one of the students to pop out. So what you want to do is you want to give them an explode value and then go from there. So we have three values, and I'm going to give 0.2 to one, 0 to other, and 0 to another one. Right? You can give like a lot of them explode values, but let's say we just want to give it to student one. And so what you want to do is you want to plot the pie. So let me get the pie from top, and then we will plot this again. So we have the sizes, the labels. Let's say we don't want any of this anymore. We want the explode to have the value. So we want to explode to have my explode. Cool. We're missing something. What are we missing? We are missing plt.show, because it will not print the result in that case. See, so it just explodes in a bit. And if you want, then you can also have a shadow on this. So I'm just gonna add a shadow equals to true. And if I'm going to run this again, then it's going to have a shadow. So some other features that you can use to just make sure that your pie chart pops out. You can apply colors to it as well, something like I'm not going to show you, but just to give you an example, you can apply colors to it as well. And now, okay, let me see and come back and see if you have any questions first. All right, so we did a lot of stuff, but what we did was basically try out some visualization techniques for data. Everything depends. Now I understand that this might seem simple when you're working with small data, as I said, but when you're working with large data sets, picking the right visualization is a make or break thing. It gives you the right answers. It helps you understand which models to use as well, because you can make decisions based on, okay, this can happen in clusters, this is labeling, so we can work with supervised data. There's a lot of things that you can do, but visualization plays an important role in all of that. Will the notebook be shared after the session? I can see, of course. So what I can do is I can check if I can share this notebook later. And the way I'm going to do that is I'm going to share it with slides in Discord. Sounds good? After the second session, by the way. So I can just combine the data and send it together. Perfect. So yes, you can try out some of these things out yourself. But let's see. Let's see if everybody is feeling good about this. Everybody has a good idea of how things are done. All right. Perfect. Okay, moving on. So in the interest of time, there's actually one thing that I definitely wanted you to know about. I wanted to show you like a grid printing, something called a mat show that we use. Another thing that I wanted you to learn was subplot. So um, I think let's start with subplot first. We'll cover what subplot is, and then we will cover what the grid is. If there is time, then we can also talk about areas, but you get the gist, right? It works the same way. So you have something called an area chart where you can plot two lines and then fill the area in between. So for that, you can use something called filled underscore between. Again, play around with matplotlib. There's a lot to do here. You can apply labels with like an X label and a Y label. You can have title, as you said. You can also have something called a legend, which is displaying your it basically labels and which displays the labels and the values associated to it. So it has like a chart to navigate the graph. So you can do all of that, but actually I think I can show you the legend here. So let's see. Plt dot, I think that's one small thing that we can cover with this at least. So it's an explode. So we did a lot of things here. We have an exploding pie chart, we have a shadow, we have the right labels, we have sizes, and then we do a PLT legend, and then we do a PLT show. So let's see what happens. So here you can see that student 1, student 2, and student 3, and along with it, the colors are displayed on the side. So it just gives you like a chart from there. So that's another thing that you can do. Okay. Great. In which channel we can find slides on Discord? I think I can post it on GHW chat afterwards. So after my second session on 11th, I will post the links to the slides that you can view. I just missed on how we plotted the first graph. I don't know how to do it. I understood the codes but can't reproduce. That's fine. If you understood the codes, that's absolutely fine. As we said, there are some errors that we saw in your code, but we can absolutely help you out at the end of the session, debug, and do things better. Sounds good? I think everyone is doing great. This is a great session. From what I think, you were able to learn some basic concepts, and in the interest of time, we were able to try out one library. Okay, so let's talk about subplot. Very important stuff. Subplot is a function which we can use again on PLT, where you can. So okay, let's look at it this way. It takes 3 arguments, right? What it does, it describes the layout of your figure. Let's say you want to print out multiple charts, and if you want to do that, you wanted your layout to be organized in rows, columns. You wanted to have different charts displayed on the same print line, and so when you're doing that, you want your first argument to tell us the rows, number of rows, the second argument to tell the number of columns, and then the third argument to tell us where this plot lies, right? So something that we're going to use here is another thing, and I think subplot is just one thing that you'll use from this, but the other thing you'll understand is how to use numpy as well. So Okay, let me. So I have some information that I can share. Let me see if I can find some data. So this is two libraries that we're using. We'll use the same thing. We'll use matplotlib pyplot, and then we'll use numpy. But I think I already have some data stored because this was a large one and I stored some data previously. So you don't need to type it down along with me. You can obviously try this later, but I'm going to use that data in the interest of time. So the plot one. So what we can do is, so we imported the matplot library. We know how to do that. We imported the numpy library. Why we did that is because you can use to create an array, but what you can also do is randomize data from this. If you want just random numbers, etc., you can do all sorts of stuff. Right now we'll just use this library to create an array. So something that is important to note here is that what we wanted to do is we want to have a subplot. So we want to use something called plt subplot, and as I said, it takes three arguments. Number of rows, so we want a total number of rows to be 2. Number of columns, we want total number of columns to be 1. And then we want in the first column for this plot to exist. So we don't want to change the library again and again. We don't want to do all of the effort again and again. We want the subplot and we want all the answers together. So this is subplot that you can use. And what we want to do when we gave it the subplot, what we want to do now is actually do our thing. We want to plot the x and y. So what this would do is it assigned the xy plot to the first subplot value in 2 rows and 1 column. So in the first column, it will first row, first column, it will give this. Let's say we have another plot. So I'm just going to get a few more values that I have saved. Just some random values, 1 to 3, 10, 20, 30, 40. And what I want to do is we're going to do another PLT subplot. Sorry, not show, not so quick. Another subplot. So second column, 2 rows, 1 column, that's the total number. And on the second one, we want this to be printed. Again, we'll do another PLT plot, x comma y. Cool. All good at this point? So now this is where we will do a PLT show, and then let's print and see what we have with us. Great. Now you can see 2 rows. I told it 2 rows, so it has 2 rows. I told it 1 column, so it has 1 column. And then in the first one, it has the first map, and then the second one, it has the second map. So this one was a straight line, linear model, linear line. This one had different points. It had different points plotted, so it can use that. So you see, it recognizes, and then you can create complex structures. Let's say you have 6 graphs that you want to plot out. All of this can be done together. Okay, great. Awesome. How should we select the colors of the pie chart? Oh, there's actually colors you can use. So remember I used shadows. In the same way you can do a comma, colors equals to, and then give it the colors array. Cool. Okay, awesome. Great. So we learned a lot of things here. And then another important thing that I wanted to show you was something called match show. This is something that we'll be using in the next session as well. So pay attention. I imported the library. Again, I'm doing this just because I already did this at the top. So I actually don't need to import the library again and again, as you can see. But just in the interest of that cell being unique and you see the entire code together, I'm doing this. Again, I have another data saved with me. So I'm just going to use that. So this is a grid that I have. A grid where it's a 2D graph, 2D grid that I have, which contains some values that I've inputted. Now, what I want to do is I want to visualize this entire grid. Now, pay attention. This is something that we use that is used a lot for images because when you grayscale them, you can actually see the pixel value. So let's say you have these values and you want again a grayscaled image. So we'll do a quick plt dot match show, something that you can use. Match show or match, I think yeah, match show is fine. We'll check. If it doesn't work, we will debug. So match show is something that you can use to print this grid. Now let's see what this does. So again, an important use case for this is with images. So as you can see, it displayed like a color set of images, but what if we do a plt.gray? So what we see here is a grayscale of all of the images. So the 0 becomes a black color and the 5 becomes a total white color, and it takes that scale and then scales the values accordingly. So when we printed 1, it was a slightly less dark color, 3 was gray, 4 was gray, is a lighter version of gray, and then 5 was white. So that's what it does. It gives you an idea of the pixelated image and how it looks like. Yes, so numbers are shades, exactly. And it gives you that value. Now, this is great tool for visualizing images, because what you want to feed is the your model is some data. You don't, like, the model doesn't understand images, right? Straight away. It wouldn't make sense for him to for the model to know what a dog is unless you actually put some associated value with it. So you can use these charts to actually mimic those values and then feed those models. Another way of training your models, but this one is just for visualization purposes. So you feed your values and then you put print it, and then that's how you see it. So numbers become shades, absolutely. All right, lot of information that we covered. So let's revisit things a bit, because I know we did a lot of them like in a go, and so you might have missed some things here or there. But just a quick recap. So what we did was we had x and y values, we plotted it, we printed a line, we see. Remember to always do a plt.show, otherwise you won't see printed images. Um, then you have bar, where you can see a bar graph. If you do a bar H, you can see a horizontal bar. You can see a histogram if you want. You can see scattered, just dots for images. Oh, another thing that I should show you here is, here we are using the marker O. But let's say you don't want to use the marker O. You wanted to use the marker star, for example. So there you go. Let's try this. And then if we run this, you'll be able to see stars instead of O's. So it wasn't like for a specific reason that I wrote O's, just to give you an idea. Okay, so next thing is dotted line. So you have a line style dotted, we tried that. Then we also tried some pie charts. We knew that it needed labels and sizes. You can also put a title here. You can also put some information as well, like some other information if you wanted to print the values itself, if you wanted to see the start, like change the start angle and try other things. If you wanted to explode the value, then you can do that. If you wanted to build a graph here, then you can do a legend. If you wanted the pie chart to have shadow, then shadow true. Here another thing is how to create arrays in a different way, and then use subplots, which is a very important feature for large data sets, as we said. And then for also match show, which is another thing that you can use. Again, matplot library has a lot of other things that you can use. For example, the area graph that I gave and as an example. But again, this is something that you can explore and continue to explore with. So based on what your use case is for your ML model, this library has a lot of visualization techniques. These are some of the basic ones for you to just get started and try with. There are different attributes and values that you can give the mod, like give your plot to tweak it to, as you can see, to make it more like better formatting, to help with visualizing stuff and help understand things better. So again, coming back to the slide, to the screen, StreamYard, just to make sure everybody is doing good. So, quick check. Any questions? Post questions in. If you're doing good, then give me a thumbs up to show me that you're like everything is good. And I know it's getting late for a few people, so I just wanted to make sure that what we talked about today, what we discussed, did like you understood that. If you have questions, I can answer those. I see that your issue was also resolved. Um, Great. Perfect. I see thumbs up. I see emojis. I see excitement. Love that. So I saw another example of this mat show is that when you think about X-rays as well. Like this is also something that you can use to visualize it if you can want to pixelated images and you wanted to break it down. Another example of this that you can use. Everything makes sense. Perfect. Great. All right. Okay, so we talked about a lot of things for Matplotlib, and yes, we tried it out. So, coming up next, as I said, next time we're going to learn a little bit about scikit learning. Lot to learn there as well. We'll also learn about an algorithm that we're going to use in building our first ML project, which is a multi-layer perceptron learning model, and then we will build our first ML project. I think we are off to a good start. I think we have a good base set. Lots and lots of things to unpack here, because I talked about a bunch of stuff regarding types, regarding the workflow, regarding a bunch of other stuff. So yes, it was indeed a full jam-packed session with a lot of things for you. So let me put this as a banner up for everyone. The second part, I'll do a quick recap in the next one if in case you wanted to just refresh your information. But it's very important that in the next session you come prepared. So take you have, I think, a day or so. uh let things settle down, understand the concepts. If you want to search something, search for it, try out things on your own, and we will be back to learn these three things in the next session. So let me put the next session details up here. So the next session is on 11th February, that is Sunday, at 7 a.m. EST. 7 a.m. EST. Let me convert some of these things for you. So 7 a.m. EST means 12 p.m. UK time, and in IST that would mean 5:30 p.m. on a as well. So hope this time works for everyone and everyone is all set to get started with a few other things. Um, in Romania, okay, I can also check for Romania. 7 a.m. Eastern to Romania time. Let's see. Okay, 7 a.m. Eastern is 2 p.m. All right. So, what will we be building? Great question. So, what we'll be using this scikit-learn and the model that I discussed that you see here to create a model that recognizes handwritten digits. Cool. Awesome. All right, excited for that. I think it's going to be a great session. I think you have a lot of knowledge about the concepts. I hope that this first session was basically to give you an overview. So now this entire week, when you study different models, algorithms, and like have different sessions on ML, it would give you a good base and foundation so that you can learn those things and grasp those things quickly. Very easy for to do as things. Yes, we will be doing some image recognition. So basically we'll be making a model that recognizes that images. We'll be using all a pre-processed data so that we don't waste time in collection and pre-processing. It's a lot of effort and a lot of headache. But yes, we'll be using pre-processed data, and then we'll be building this first ML model. Excited for the next session. Great. I am excited to share that with you as well. How much will that last? I think you mean the timing of the session. So these sessions are roughly around uh, like an hour and a half and 2 hours, depending on Q&A, how folks work, etc. So great. The next session. Yes. Okay. Thank you so much. Thank you so much. Always love hearing this. Awesome. So, any questions so far? I know we are talking about Hack with Sashrika. We will be back with another Hack with Sashrika again. Just a quick reminder, if you haven't already, it's your time to check into hackp.ac/hack with Sashrika AI ML week. I know, long one. Let me do this. Let me actually paste this for you in the chat so that you can click on the link and then go from there. So make sure that you check in and register for these events. Yeah, that's how you earn bragging points. So yes, this entire week is a great celebration. We covered a lot of stuff. I hope you enjoyed the session and I hope you had a great time. If you have questions, I'm still here for a few more minutes to answer those. But yeah, I think we are off to a good start. How does it take to contribute to some of these open source packages like scikit-learn? How does it Sorry, I'm not sure if I get your question, but if you mean that how to contribute to these open source packages, so you can actually, so let me see if scikit-learn is open sourced on GitHub. But then if it's open sourced, it is open sourced on certain platforms, and then you can contribute to it there. Yes, scikit-learn is a machine learning in Python, which is open sourced on GitHub, so you can actually use this to work on some of the issues they have, create pull requests, and go from there. Okay, and then could we get a link for Discord? Yes, I think that's discord.mlh.io, if I remember correctly. Let me paste that for you. Cool. Awesome. All right. I posted the link. The next session, no, the next session is also on Twitch. Any of the sessions for Global Hack Weeks, if Hack Week is on Twitch. So just to clear the confusion, the Discord is just for you to hang out, exchange session notes, talk about building things together if you want. Yeah. For the AI section part, is that package used to? I'm not sure if I get your question. Please feel free to reframe it. But if I understand correctly, you're talking about the package scikit-learn that we're using for machine learning. Yes, we'll be using a model in scikit-learn, which is already like a model which scikit-learn offers to process our data. Great, awesome. All right, with that, we are at the end of this session. So excited for the next one. The next one is on Sunday. Be ready, 12 p.m. UK time, 7 a.m. Eastern. The next session details are here. Stay tuned for a session with Dimmer shortly. He is going to talk about, let me see what Dimmer has in store this time. Dimmer is going to talk about AI in comp sci versus AI in game dev. Ooh, exciting session. So stay tuned. In a few minutes, he will be coming here, right here on Twitch, to chat with you about it all. So yes, feel free to take these 10 minutes, a few minutes to relax, and then come back here for another great jam-packed session. Awesome. All right. Thank you so much, folks. It was great hacking with you. All right. See you at the next session, 11th February, Sunday, 7 a.m. Eastern. All right. See ya.